then this intelligent life might be very close to us. So theoretically, and purely theoretically, we might be able to communicate with this intelligent life by exchanging strong gravity wave sources.
So who knows, maybe someday we'll develop the technology and use gravity waves to actually communicate with other worlds. Yeah, hey, it's Brian. How you doing?
Brian. What Jabby Woofalapa Jabba Simpsons?
We don't really know if parallel universes could have a real impact on us. But there is one very controversial idea which said they've already played a major role. In fact, it gives them credit for our existence.
As the classic story goes, the vast universe we see today was once extremely small, unimaginably small. Then, suddenly, it got bigger. A lot bigger during the dramatic event known as the Big Bang. The Big Bang stretched the fabric of space and set off the chain of events that brought us to the universe we know and love today. But there's always been a couple of problems with the Big Bang theory. First, when you squeeze the entire universe into an infinitesimally small but stupendously dense package, at a certain point, our laws of physics simply break down. They just don't make sense anymore.
The formulas we use start giving answers that are nonsensical. We find total disaster. Everything breaks down, and we're stuck.
And on top of this, there's the bang itself. What exactly is that?
That's actually a problem. The classic form of the Big Bang theory really says nothing about what banged, what happened before it banged, or what caused it to bang.
Refinements to the Big Bang theory do suggest explanations for the bang, but none of them turn the clock back completely to the moment when everything started.
Most people come at this with the naive notion that there was a beginning, that somehow space and time emerged from nothingness into somethingness.
Well, I don't know about you, but I don't like nothing. Do I really believe that the universe was a big bang out of nothing? And I'm not a philosopher, so I won't say, but I can imagine to a philosopher that is a problem. But to a physicist, I think it's also a problem.
Everyone admits there are problems. The question is, can string theory solve them? Some string theorists have suggested that the Big Bang wasn't the beginning at all, that the universe could have existed long before, even forever. Not everyone is comfortable with the idea.
I actually find it rather unattractive to think about a universe without a beginning. It seems to me that a universe without a beginning is also a universe without an explanation.
So what is the explanation? What if string theory is right, and we're all living on a giant membrane inside a higher dimensional space?
One of the ideas in string theory that was particularly striking to me and suggested perhaps a new direction for cosmology is the idea of brains and the idea of brains moving in extra dimensions.
Some scientists have proposed that the answer to the Big Bang riddle lies in the movements of these giant brains.
It's so simple. Here's a brain on which we live, and here's another brain floating in the higher dimension. There's absolutely nothing difficult about imagining that these collide with each other.
According to this idea, sometime before the Big Bang, two brains carrying parallel universes began drifting toward each other. Until
all of that energy has to go somewhere. Where does it go? It goes into the Big Bang. It creates the expansion that we see, and it heats up all the particles in the universe in this big fiery mass.
As if this weren't weird enough, the proponents of this idea make another radical claim. The Big Bang was not a special event. They say that parallel universes could have collided not just once in the past, but again and again. And that it will happen in the future. If this view is right, there's a brain out there right now headed on a collision course with our universe.
So another collision is coming, and there'll be another Big Bang, and this will just repeat itself for an indefinite period into the future.
It's an intriguing idea. Unfortunately, there are a few technical problems.
Well, that was a very ingenious scenario that arose naturally within string theory. However, the good old problems creep back in again.
The fact is, we don't really know what happens when two brains collide. You can wind up with the same situation we had with the Big Bang. The equations don't make sense.
They have to make a lot of assumptions in their models, and I don't think they've really solved the problem of the Big Bang in string theory.
If string theory is the one true theory of the universe, it will have to solve the riddle of the Big Bang. And there's a lot of hope that someday string theory will succeed. But for now, there's also a lot of uncertainty. As promising and exciting as the theory is, we don't entirely understand it.
It's as if we've stumbled in the dark into a house, which we thought was a two-bedroom apartment, and now we're discovering is a 19-room mansion, at least, and maybe it's got 1,000 rooms, and we're just beginning our journey.
So, how sure are we that the universe is the way that string theory describes it? Is the world really made up of strings and membranes, parallel universes, and extra dimensions? Is this all science or science fiction?
Well, the question we often ask ourselves as we work through our equations is this just fancy mathematics, or is it describing the real world?
These exercises in our imagination and mathematics are all, at the end of the day, subjected to a single question. Is it there in the laboratory? Can you find its evidence?
String theory and string theorists do have a real problem. How do you actually test string theory? If you can't test it in the way that we test normal theories, it's not science, it's philosophy. And that's a real problem.
Strings are thought to be so tiny, much smaller than an atom, that there's probably no way to see them directly.
But even if we never see strings, we may someday see their fingerprints. You see, if strings were around at the beginning of the universe, when things were really tiny, they would have left impressions or traces on their surroundings. And then, after the Big Bang, when everything expanded, those traces would have been stretched out along with everything else. So if that's true, we may someday see the telltale signs of strings somewhere in the stars.
But even here on Earth, there's a chance we can detect evidence of strings. This past year in Illinois,